Hello and good afternoon my dear kids. Welcome back once again to this short tutorial video for class 7 students. And since we are following the geometry section, so in this video too we will be doing few geometric about we'll be learning about one of the geometric figures, okay, that is triangles. Okay, so first of all, triangles. And since I have already taught you that how a geometric figure is made, so I guess you know that how a triangle is made as well. Okay, you must be familiar with triangle, isn't it? So simple, a triangle is a closed figure having 3 sides, 3 angles and 3 vertices. So you know about the vertices and all. Okay, the sides and the angles, these are like, yeah, the angles also. The term angles and vertices, I guess you can recall from your previous video. Okay, what I have taught in the previous videos. So 3 sides, sides is an easy one, isn't it? So 3 angles and 3 vertices. Okay, angles and vertices, recall that, okay, from your previous knowledge. So here we have triangle ABC, usually written as C, the symbol for triangle, a small triangle. Okay, so triangle ABC with 3 sides as AB, BC and CA. So here I have drawn triangle ABC with sides as AB, BC and CA. See, 3 angles, that is angle ABC, BCA and CAB. Okay, angle ABC, which that means this angle, isn't it? Because I have already told you the vertex is always written in the middle, isn't it? ABC means this angle, BCA means this angle, and CAB means this angle, isn't it? Or say, if you just directly write the name of the triangle, like for example, if while doing sums and all, if you get a triangle and it's a mixed one, okay, the triangles are mixed one. So when once you mention triangle, some like here, if I have mentioned in triangle ABC, I could have just simply written angle A, angle B and angle C as well. Okay, but if the figures are mixed, then I recommend you to use 3 different points. Okay, the vertex always in the middle. Okay, and the 3 vertices A, B and C. Okay, A, B and C are 3 vertices. As you know why they are called vertices, isn't it? Because they are the points where an angle is formed, isn't it? Okay, so a closed figure having 3 sides, 3 angles and 3 vertices is known as your triangle. Okay, okay. So the next topic here we have is classification of triangles. Okay, like categorizing triangles. Okay, categorizing triangles. So classification of triangles. Triangles can be classified in 2 general ways. So actually triangles are classified in general two general ways. So first of all is by sides. Okay, that means what we are doing is we are classifying triangles, remember. Okay, so first of all is equilateral triangle. When all the 3 sides of a triangle are equal, then the triangle is known as an equilateral triangle. Simple. When all the 3 sides of a triangle are equal, then the triangle is known as an equilateral triangle. So see the markings on the figure. Okay, this is very important, the marking on the figure, because in geometry what happens is the marking will tell you the marking will give you will tell you about the figure that is given for you during your while you do your sums regarding the in geometric section. Okay, so see here I have marked with this one small cut mark like in the sides, isn't it? AB on the side, BC on the side, AC. So this means these 3 sides are equal. Okay, with 1 mark, 1 cut. Okay, so okay, known as an equilateral triangle. In an equilateral triangle, all the 3 angles are also equal. Now see, since we are doing classification by sides, so we are not actually dealing about the angles, isn't it? But here still I have said in an equilateral triangle all the 3 angles are equal. So what happens is, if it's an equilateral triangle, now see, if it's an equilateral triangle, then all the 3 angles will also be equal. That's what I'm trying to say. Okay, if the triangle is equilateral, that means if the 3 sides of a triangle are equal, at that time all the 3 angles will also be equal. Okay, okay. So moving on to the next one we have here is isosceles triangle. So in an isosceles triangle what happens, let's see, when 2 sides of a triangle are equal, then the triangle is known as an isosceles triangle. When 2 sides are equal, so see here I have drawn angle, one of the triangles ABC I have drawn 3 triangles, but what is the difference between those 3 triangles is, see the marking. See here I have marked AB, side AB and BC, here I have marked AB and CA, and here I have marked AC and CB. See I have picked 3 different sets of equal sides, isn't it? For this triangle these 2 sides are equal, for this triangle these 2 sides are equal, and for this triangle these 2 sides are equal. So see, what is the importance of this is because, see, In an isosceles triangle, the angles opposite to equal sides are equal. That means simple. In an isosceles triangle, two sides will be equal. Okay. Now, one more thing you can conclude, that is two angles will also be equal. Okay. Now, which two angles are equal? That is very important. Okay. See, because that is why, see, the marking is important. That's what I said earlier as well. See, in an isosceles triangle, the angles opposite to the equal sides. The angles opposite to the equal sides. So see, for these two sides, these are equal sides, isn't it? Which is the opposite angle for this side? This one. I have marked arrow here. See, opposite angle for this side is this one, isn't it? And opposite angle for this side is this one. That means for this figure, angle A will be equal to angle C. Angle A will be equal to angle C as well. Okay. And for this triangle, see, again, this is also an isosceles triangle, as I have marked with two sides with just, see, a small cut, isn't it? That means AB is equals to AC out here, isn't it? And what we know, angle opposite to the equal sides are equal. So for this side, the opposite angle is angle C. And for this side, the opposite angle is angle B, isn't it? So here, for this isosceles triangle, angle C is equal to angle B. Now see the difference because of the sides, isn't it? Here it was A and C was equal, here it was B and C. So you cannot just pick randomly two equal angles in an isosceles triangle. Okay, this is why I have drawn all the three possible, okay, figures. So here for this one, AC is equals to BC, or you can call it CB as well. AC is equals to BC or CB. So okay, now which is the opposite angle for this side? Angle A, isn't it? Which is the opposite angle for this side? Angle B. So in this figure, angle A is equals to angle B. Okay, two sides, two angles, and they are known as, it's known as isosceles triangle. Okay, now for the next one we have here is a scalene triangle. So scalene triangle, when a triangle has no equal sides or angles, then the triangle is known as scalene triangle. Simple. When all the three sides are unequal, see, that is what I have marked with here. See, one cut, two cut, three cut. See. Similarly, I have, see, look at the angles, the arc in the angle, 1, 2, 3. So this represents, or this means, it's a scalene triangle with all the three unequal sides and with all the three unequal angles. Okay. Okay. Now by angles. So since we are doing classification, isn't it? Up to here it was classification on the basis of sides. Now we will be doing classification on the basis of angles. Okay. So first of all, an acute angled triangle. Acute angle triangle. So a triangle with all the three angles measures greater than 0 degree but less than 90 degree. So we know that an acute angle means it's greater than 0 degree but less than 90 degree, isn't it? So if a triangle with all the three angles measures greater than 0 degree but less than 90 degree, then the triangle is known as an acute angle triangle. See, if all the three angles, they may be three different angles. Okay, they may be three different angles, but if all the measure of those three angles is below 90 degree but greater than 0 degree, then that time that angle is known as an acute angle triangle. Okay. Okay. Now the next one we have here is a right angle triangle, and this triangle is a very important triangle. Okay, right angle triangle. And why so? You'll get to know it afterwards as well. Okay, because we will be dealing few topics on simply on this triangle as well. Okay, it's a very important topic. That's a very important topic. Triangle, remember that. Right angled triangle. Now see, why it's known as right angle triangle? A triangle, we know that right angle means 90 degree, isn't it? A triangle with one of its angle equal to 90 degree. Suppose we go have a triangle and one of the angles is 90 degree. Then at that time, the triangle is known as a right angled triangle. Okay, so here we have a right angle triangle. And remember this symbol. Says previously how we used to denote an angle like this with an arc, isn't it? But here I have, see, marked with a different symbol, isn't it? Now this symbol is actually for 90 degree. Okay, whenever you see just this symbol, it means, remember, whenever you see this symbol in your any sum or in any other figure as well, then that time this symbol means 90 degree. Okay, why it is so see, and what I have given here is a right angle triangle has a particular name for its sides as well. See, the angle, the side opposite to 90 degree, the side opposite to 90 degree is always the longest side of a right angle triangle, and it's known as hypotenuse. Okay, the side opposite to 90 degree is always the longest side of that particular right angle triangle, and it's known as hypotenuse. Now the side which is with it on a vertical position, is known as height or altitude or perpendicular as well. Okay, so perpendicular, actually perpendicular means 90 degree, isn't it? So that is why it is given. See, height, altitude or perpendicular. It may be this line, that is this side, AB side in this triangle, particular triangle, can be called as the height of the triangle as well, the altitude of the triangle or the perpendicular of the triangle as well. Okay, and the bottom part is known as your base or adjacent. Remember, try to remember the names as well. Okay, this side can be called as height. Either they can call it as height, because sometimes they will be using height, sometimes they will be using altitude, or sometimes they will be using perpendicular. Okay, that is why I have given all the three different names for this side. And this side has got two names, that is a base and adjacent. It can be called as base, it can be called as adjacent. Okay, so then don't get confused with this. Okay, and this side, it just has one name, that is hypotenuse. Okay, okay. And the third type of angle, that is the third type of triangle, that is we get through classification of triangles on the basis of angles, is an obtuse angle triangle. Now you know about an obtuse angle, isn't it? An angle which is greater than 90 degree but less than 180 degree is known as obtuse angle. So there may be some relation between them, isn't it? So let's check it out. A triangle with one of the angle measuring greater than 90 degrees. See, greater than 90 degree but less than 180 degree is known as obtuse angle triangle. Simple. Okay, if one of the angles of the triangle is greater than 90 degree but less than 180 degree, then that time that triangle is known as an obtuse angled triangle. Okay, okay, okay. Now median of a triangle. Now this is also an important part in here. Okay, median of a triangle is a line segment joining a vertex to the midpoint of this side opposite to the vertex. A median of a triangle is a line segment joining the vertex to the midpoint of this side opposite to the vertex. Now what does midpoint means? Midpoint means a point which divides a certain line segment or a line into two equal parts. Okay, so in this one, see, I have drawn a triangle ABC, and as you know, A is also a vertex, isn't it? I have drawn a line vertex such that if the vertex, the point where I touched BC, divides BC into two equal halves, that is, in this one what has happened is BD will be equal to DC. See, that is why I have drawn, see, one arc out here as well. So at that time, a line which divides a line starting from one of the vertex, if it goes to the opposite side and divides the opposite side into two equal halves, and at that time the line is known as your median. As simple as that. Okay, let's check out here as well. See, ABC, from the vertex B I have pulled a line, I have drawn a line, and towards AC, that is the opposite side is AC, isn't it? The opposite for this vertex is AC, so I have drawn a line towards the opposite side and divided the opposite side into two halves. That is the midpoint. See, I have touched the midpoint. So that is why I say I have drawn one arc here as well. Okay, and that time this line, and this time this line, that is BD line, is known as your median of this triangle ABC. Okay, similarly for here as well, I have drawn ABC. The vertex, I have picked the vertex C, and from C I have drawn a line opposite to the towards the opposite side. That the opposite side was AB, and joined a midpoint. Midpoint, as I have already said, the point which divides a side or a line segment. Actually, AB is a line segment, isn't it? AB is a line segment, but here it's AB is a side of the triangle, isn't it? So it has divided AB into two equal halves. See, that is why I have marked one. See, with one cut. Okay, so at this time the CD is known as your median of this triangle ABC. Okay, okay. Now altitude of a triangle. See, you recall altitude, where we have just heard the term altitude in a right angle triangle, isn't it? See, altitude of a triangle. An altitude of a triangle is the perpendicular drawn from the vertex to the opposite side. See, perpendicular drawn from the vertex to the opposite side. Perpendicular means altitude and perpendicular were the same things, isn't it? That means both of them form 90 degree angle as well, isn't it? So see, that is why if a triangle is like this, okay, a simple triangle, and from A there is a vertex point, and I have drawn a line which is perpendicular to the other side, that means it makes an angle 90 degrees. So that is why I see, I have already told you with the figure, the symbol as well, isn't it? Suppose we got this symbol, then at that time it's known as, that line is known as your altitude of the triangle as well. Okay, similarly for this one, it's a right angle triangle, as you know already. AB is the altitude, isn't it? Because it is making 90 degree angle. See, it's because These lines are perpendicular. AB and BC can also be known as perpendicular lines, and this is perpendicular. Okay, 90-degree angle is formed, so it's altitude of a triangle. Okay. Now interior and exterior angles of a triangle. So interior, as the term means, simple, inside the triangle, isn't it? Exterior means outside the triangle, simple. Okay, interior and exterior. Okay, so why I'm telling you this is because of this. See, we have one property of an exterior angle property. It's known as exterior angle property. Okay, so what does the property states is an exterior angle of a triangle is equal to sum of its interior opposite angles. An exterior angle of a triangle. Remember, if we extend the sides of the triangle, then you may get various exterior angles, isn't it? Like for example, in this one, see all these angles, that is all the angles formed outside the triangle, they are exterior angles, simple, isn't it? So what does the statement about, what does the exterior angle property of a triangle states is that an exterior angle of a triangle is equal to sum of its interior opposite. Exterior angle will be equal to sum of its interior opposite. Interior opposite as well as its sum. That means in this one, angle C will be equal to angle ACD, not angle C. Okay, or you may confuse with angle C with this one, isn't it? Angle. So that is why I said C. Whenever you get different angles on the same point, then at that time you use 3 different points to denote an angle. Okay, so that is why I am saying angle ACD. Angle ACD will be equal to angle CAB, that is this angle, and angle ABC, that is this angle. This is the exterior angle property of a triangle. Remember, an exterior angle will be equal to sum of its interior opposite angles. Okay, sum of its interior opposite angles, because you know that the relation between these two angles, they are linear pair, isn't it? They are linear pair. So interior opposite angles. Okay, an exterior angle will be equal to sum of its interior opposite angles. So similarly, here in this one I have shown exterior angle towards this side, that is angle ABD in here, ABD or DBA, you can call it as DBA also, isn't it? ABD is your exterior angle. So what we just learned, an exterior angle will be equal to sum of its interior opposite angles, isn't it? Interior opposite angles. Okay, so here ABD will be equal to BDC and BCD. Okay. Okay, so okay, now angle sum property. Okay, now this one is also very important. Okay, angle sum property of a triangle. So the statement simple as the statement says. See, the sum of all the 3 angles, 3 interior angles of a triangle is 180 degree. So no matter how much bigger or how smaller you draw a triangle, if the sum of interior angles is not equal to 180 degree, then it's not valid. As simple as that. Okay, so it has to be, that is the sum of interior angles of a triangle has to be always equals to 180 degree. Like for example, in this triangle ABC, since there were no other exterior angles and all, so that is what I have just directly written angle A plus angle B plus angle C. Okay, angle A plus angle B plus angle C will be equal to 180 degree. That's it, and we are done here. Okay, what you need to remember from this topic is that, this point is that, whenever in a triangle, if we add the 3 interior angles, it's 3 interior angles. Okay, whenever in a triangle, if we add all the 3 interior angles, we'll get 180 degree. That's it. Okay, let's just recall one of the topics from the previous one. What we have done on the previous one, I said that in an equilateral triangle, all the 3 angles and all the 3 sides are equal, isn't it? 3 angles and all the 3 sides are equal. So see, if we take all the 3 angles as x, now what we just learned, we learned that when we add all the 3 angles, we'll get 180 degree, isn't it? If we just take all the 3 interior angles as x, so that is what I've written here. See, x plus x plus x equals 180 degree using the angle sum property. Now you know the drill, isn't it? You know the step. So 3 like terms, x plus x, so it will give you 3x. 3x equals 180 degree. Now x goes to 3 goes to other side, divides 180. So you will get x equals to 60 degree, isn't it? Now from here, what we just learned is that in an equilateral triangle, all the 3 sides are equal, we know that. All the 3 angles are equal, we know that. But what we just learned from here is that all the 3 angles is equals to 60 degree. That's what we just learned from here. Okay, in an equilateral triangle, always all the three sides will be equal. Okay, well and fine. All the three angles are equal. Well and fine. And what we just learned? We learned that all the three angles are also equal to 60 degree. The measure of the three angles will be equal to 60 degree. Okay? Okay. So I hope you kids understood today's lesson. Okay? So till then, stay safe, take care, and keep in touch, stay updated for more videos, okay, and infos. Take care, bye bye.